Hello guys, welcome to Dance IT Network, and this will be my last video tutorial in CCNA 3. Our last topic would be EIGRP. Based on my research, EIGRP is not included to the CCNA exam, but it is essential to know its function and how to configure it. Maybe, who knows, they might include this to the CCNA exam soon. Okay, before we start configuring EIGRP, let me give you a little bit information about it. So EIGRP stands for Enhanced Interior Gateway Protocol, and it is a Cisco proprietary, meaning it is only compatible or applicable to Cisco devices. And number two, it has this feature on equal cost load balancing, the ECMP. Well, EIGRP is the only protocol that has this feature in IGP. Well, as we go along, we'll talk more about this unequal cost load balancing. Number three is much faster compared to RIP and has a better distance vector routing protocol. If you are familiar on how to configure RIP, then it will be easy for you to follow along on this video tutorial. And last, EIGRP multicast address is 224.0.0.10. Okay, let's start. So let's get three routers. Let's get 2911, okay? And let me label this as R1, another one, 2911, same model. So I'll label this as R2. And next, this one would be then the R3, okay? And we'll connect them using straight 2 cable. So from R1 gigabit 0/0 and then gigabit 0/0, and then from here R2 gigabit 0/1 and gigabit 0/1. Okay, I will close this. All right, and from R1 to R2, we'll use a network. Let's say we'll use this 192.168.1.0 and /29. Okay, so this is a subnetted network. Well, if you do not know how to do subnetting, then I guess is you need to do some practice, and I will put a link on the description below for you to watch and learn. Okay, so this is subnetted 1.0/29, and let's use another subnetted network in here. Let's say 192.168.1.8 and /29. Okay. All right, and let's start configuring the IP addresses. Let's start here in R1. Okay, so on this network, the 1.0/29, the first usable IP address that we can use in here is the 1.1. So we'll use the 1.1 and this gigabit 0/0 under the R1, and we'll use the 1.2 on this gigabit 0/0 under the R2. Okay, let's do that. So I'll open the R1. I'll hit enter to get started. I'll type here enable to go to privilege mode, then comp T to go to global config mode, and let me just change the host name first. Let's say change the host name to R1. Okay, so from router to R1. Okay, there you go. And then let's go to the interface gigabit 0/0, enter, then IP address 192.168.1.1, then space subnet mask is 255.255.255.248. Okay, it is 248 because it is subnetted. It is a /29. Okay, I'll hit enter and I'll type here no shutdown to turn on the interface. There you go. Control C, and let me just save the configuration by typing right, and I'll move to this R2. Okay, so gigabit 0/0 command line, hit enter to get started, enable, comp T, global config mode, and let me just change host name to R2, then interface gigabit 0/0, then IP address 192.168.1.2, then 255.255.255.248. Okay, all right, and then I'll type here no shutdown, turn on the interface. There you go. And let's move to this gigabit 0/1. All right, so this is the network IP address, right? So 1.8/29. So the first usable IP address is the 1.9. We'll use it in here, and then the 1.10 over here on the R3. I mean to the R3. Okay, So let's do that. So gigabit 0/1. So I'll type exit first, then interface gigabit 0/1. There you go. Then IP address 192.168.1.9, and then 255.255.255.248. There you go. Then no shutdown. Okay, Control C, and let me save the configuration by typing right, and then I'll close this, and let's move to the R3. All right, let's do it fast because registering IP address is just easy. Hit enter, enable, Comm T to go to global config mode, and then host name. I'll change this to R3. There you go. Send interface gigabit 0/1, and then IP address 192.168.1.10, right? Okay, and then 255.255.255.248. There you go, 248. Hit enter, and then no shutdown. Turn on the interface, then Control C, and let me save now the configuration by typing right. There you go. Let us also get a two computers so that we can perform a communication test. And let's get one computer to this R1, another computer here to this R3, and straight through cable. We'll plug it to the gigabit 0/1 and then to the fast Ethernet. Same thing in here, R3, gigabit 0/2, then fast Ethernet. Okay, and we'll use the network in here. Let's say, let's put them all on the /29. So 192.168.1 that this will be then 16, then /29. And over here, 192.168.1.24, then /29. Okay, all of them are on the /29. Okay, just to make it easy. And first available IP address that we can use in here, the 1.16 is the 1.17. So we'll use the 1.17 to this router 1 to the gigabit 0/1. This will also serve as the default gateway, of course, to this PC. Okay, so R1. Okay, I'll hit enter to get started. Enable to go to the privilege mode, and Comm T to go to global config mode, and then interface gigabit 0/1. Then IP address 192.168. Well, this should be then 1.17. Okay, and then 255.255.255.248. Okay, then I'll type here no shutdown to turn on the interface. There we go. Control C, and let me now type right to save the configuration, and I'll type exit, and I'll go to this PC in here, desktop IP configuration, and should be 192.168.1. Should be 18. Okay, and then subnet mask, it should be 248, and then default gateway is should be 192.168.1.17. Okay, there you go. Close this, and let's try to ping the gateway. Command prompt, type ping 192.168. See here, 1.17, and it's working. Okay, and let's do the same thing over here. Okay, so I skipped the part in registering the IP address to this computer and to this router 3 to save time in this video tutorial. Anyway, registering an IP address is just easy, and that is not our main topic for today. Okay. All right, so let's proceed in configuring the EIGRP to this network. All right, so in this R1, let's start in here. So this R1, okay, it knows how to reach this network 1.0 and 1.16 because they are connected to the router's 1 interface. All right. However, this R1, it doesn't know how to get to this network, the 1.8 and 1.4, because it is not connected to the R1's interface. Same thing on this R2. It knows how to reach this network, the 1.0 and 1.8, but this R2 doesn't know how to reach this network, the 1.24 and 1.16, because it is not connected. And same thing in here on this R3. Okay, well, for them to form a communication and adjacency, then we need to put their networks, okay, per router to the EIGRP routing table. So for example, here in this R1, we'll put this 1.0 and 1.16 to the EIGRP routing table, and this R2 will put the 1.0 and 1.8, okay, and in this R3 we'll put the 1.24 and 1.8. All right, so let's proceed. Let me open the R1. I'll hit enter to get started. Type here enable, then comp T to the global config mode, and then I'll type here router EIGRP, then space question mark. So we have here options from 1 to 65,535. So let's just use the first one, the autonomous system number, let's say number 1. Okay, I'll hit enter, and then let me type here question mark for you to see what are the available commands that we can use in EIGRP. Okay, the first one that we need to use in here, the auto summary. Okay, so we'll put here no auto summary. Hit enter. And the reason why I put this command no auto summary, it is because we are using a subnetted networks. All right, they are all on a /29. If we will not enable this command, the no auto summary, then all of these networks will be summarized into just one network, which is 1.0, and we don't want that to happen. All right, but anyway, though, if you are using a classful IP address, then you can disable the this command then, all right, by typing um, auto summary instead of no auto summary. Okay, all right, and then next is we'll use this command EIGRP, and then space question mark, and I'll type here router dash ID, then space question mark again, and we need to specify a router ID. All right. Well, if you will not configure this, all right, what will happen is this router will copy the highest virtual IP address that is inside this router number 1, but we did not configure any virtual IP addresses, right? So the second thing that the router 1 will do is it will copy the highest IP address to its interface. Well, we do know that the highest IP address to this router 1 is the on this gigabit 0/1, which is 1.17, because in here the gigabit 0/0 is 1.1, so it will copy the 1.17 to become its router ID. Okay, but on this tutorial, since we are on the R1, let's make it then 1.1.1.1. Okay, so too easy to identify, so that if ever that this routers, okay, will form an adjacencies, then if we're able to see the code 1.1.1.1, then we do know that that is the router number 1. Okay, so let's do that. So just 1.1.1.1. There you go. I'll hit enter. Okay, and then next we need to put the this network, so 1.0 and the 1.16. All right, we'll do that. I'll type here network, and then space 192.168.1.0. Okay, and then space, and then question mark. So we need to put the EIGRP wildcard bits. All right, so instead of typing 255.255.255.248, we need to type then 0.0.0.7. Okay, because 255 minus 248 is 7. Okay, all right, so let's do that then. It should be the wildcard bits. All right, so 0.0.0.7. Okay, and then next we need to put the 1.16. Okay, let's do that. So network, then 192.168.1.16. Okay, so this time, let's say I don't want to put it on the wildcard bits. Let me just use the the subnet mask as it is. Okay, so 255.255.255.248, and let's see though if the router will accept the command. And here we go. So I think it's working. All right, and let me type here Control C, and let me save the configuration by typing right. I'll type here show run to view the running configuration. Spacebar, 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 spacebar. Okay, and scroll up. And as you can see here, all right, so we type this command. So router EIGRP to enable the EIGRP routing protocol. All right, so one autonomous system, and then router ID we put it on the 1.1.1.1. Okay, so this is the network 1.0, and as you can see here is the inverse format. All right, so 0.0.0.7, and same thing though on this 1.16. Even if we did not put the wildcard, all right, still is the router accepted the command and it put it automatically to 0.0.0.7. Okay. All right, and let us now proceed to the next router, to the router number two. I'll open the R2. I'll do the same thing on the R1, command line interface. Let me just spread this. I'll hit enter, then enable, COM-T, then router EIGRP. So it should be same autonomous system number, okay? So that they can form a adjacency. If we'll put this on a different autonomous system number, then they they would not be able then to form a communication and adjacencies. Okay, so same. All right, and then I'll type here no auto summary. All right, and type in here EIGRP. Right, and then the router dash ID. So since we are on the R2, let's put it on the 2.2.2.2, and then the network. So networks are 1.0 and 1.8. Okay, so all slash 29. So network 192.168.1.0. Okay, and let me just put it 0.0.0.7. And okay, so as you can see here, um, as we enter this command, it formed an adjacency. Okay, so EIGRP1 neighbor, so it was able to detect the 1.1. All right, and new adjacency, and that is good. I'll hit enter in here, and let me input the next network. I'll just change this 1.0 to, let me 1.8. Okay, all right, and let me hit enter, then control C, then let me save the configuration. I'll close this, and I'll do the same thing on the R3 as well. Command line interface, hit enter, and enable, COM-T, and router EIGRP, then same autonomous system number 1, and then no auto summary. Okay, and next would be then the EIGRP router dash ID. Let's say here 3.3.3.3. There we go. And the networks are to be then the 192.168.1. This is the 8 and also the 1.24. Okay, so 0. So let's try here. Let's try the 255.255.255.248. Okay, all right, there you go. All right, so agency is formed. All right, so 1.9. Okay, was able to see it. That's good. And hit enter. And next network should be then, I'll change this to 1.24. Hit enter. Okay, then control C. Let me save the configuration. All right, now let me type here show run. View the running configuration. Let's double check. Scroll up. So as you can see here, so we enable the EIGRP autonomous system number 1, then the router ID 3.3.3.3 and 1.8. So even if we enter the subnet mask, okay, on the 255.255.255.248, still is it put it automatically the wildcard though 0.0.0.7. Okay, same thing in here 1.24 and then 0.0.0.7. All right, there you go. So I'll close this. And one thing that I want to do in here is to this R1 and R3 is I would like to put a passive interface to this gigabit 0/1 so that the EIGRP packets will not go to this computer. Well, it's because this computer does not really understand EIGRP. And the only thing that can understand EIGRP are routers, right? All of these routers. So to save bandwidth and to avoid the packets to go to this computer, let's just block it, all right? So go to this R1 and then let me spread this, hit enter, enable, then Comm T to go to global config mode, and I'll type router EIGRP. So same thing, same command. All right. So router EIGRP autonomous number one. Okay, and let me type question mark for you to see the available commands. So we use this auto summary. We'll use these. We use the EIGRP, and we use the network, and we need to use this passive then. All right. So I'll type here passive dash interface, all right, and then I'll space question mark, and we need to put this gigabit 0/1. Okay, I'll just type here gigabit 0/1 to block. I mean to block the EIGRP updates. Okay, all right, there we go. And Control C. Let me save the configuration, and I will also do the same thing on this R3. Hit enter, enable, COM T, right, and then router EIGRP1. All right, and let me type here passive. Let me hit the tab on the keyboard, all right, to make it fast, and then gigabit 0/2. Okay, gigabit 0/2. There we go. Control C, and then let me save the configuration. Close this. Now let us check the routing table. So let's open the R1 first. Let me hit enter to get started. Enable, and then I'll type here show IP space route. Okay, let me spread this. Okay, and if it's letter D, all right, that stands for EIGRP. Okay, so looking on the routing table, so let's find the D. So this is the D stands for EIGRP. So this is it, the first one. So as you can see, is it can see this network, the 1.8/29. So it has a 90 for the administrative distance, and this is the metric 3072. And via means next hop. All right, so 1.2, this is the router 2 to the gigabit 0/0. So as you can see here, this is the router 1 going to this router 2, and this is the gigabit 0/0, and this is the 1.2, okay, IP address, right? And let's check the next route. All right, as you can see here, the next one is 1.24, so it can actually see the 1.24 over here, right? Okay, and same. So if it's EIGRP, the administrative distance should be 90. Okay, and if we will compare the metrics, all right, this is a bit higher. Well, why? It's because it's far, all right, compared to the 1.8. So for this router 1, so it needs to go one hop, all right, and to reach the 1.24, it needs to go two routers, all right, so R2 and R3 to reach the 1.24. So that is why the metrics is a bit higher compared to this 3072. And via next hop, so it goes to the 1.2 and gigabit 0/0. Okay, and if that is the case, then if it is displaying to the routing table, then we should be able to ping. Let's try. So I'll open this PC command prompt, and let me type here ping 192.168.1.26, and as you can see here that we can ping. Okay, let us also try to view the routing table to this R2. So I'll open the R2. Let me spread this, hit enter, enable, and then show IP route. Okay, or I can also put here show IP route space EIGRP, just the EIGRP only. All right, we'll do that. Okay, so as you can see here, we have here two routes for EIGRP. It can see the 1.16 and it can also see the 1.24, right? So slash 29. All right, so this is the 1.16, and this is the 1.24. Okay, so they have the same metrics. All right, since they're both one hop away, and the ports are same gigabit ports. All right, and it should be all the same, right? Okay, and if I'll type here, let's say I will remove the EIGRP, I'll just type show IP route, then you'll see all of the routes, all right? The connected, okay? Or I can also type here, let's say I'll make this just, say connected, all right? Let's try that. There we go. So all you can see here is just the connected routes. Okay, so I added another router in here. So this is the R4. I'll click this. You see that it's R4. And the reason why I add this router is for me to demonstrate to you how is the ECMP is working, the unequal and equal load balancing in the EIGRP. Okay, so this is the R4, and I connect this R4 to this R3 using a straight through cable, and another straight through cable in here from R4 to R1. Okay, and I already registered their IP addresses, and the network that I use over in here is the 1.40/29, and the first usable host is registered on this gigabit 0/0 under the R3, and the next available is registered on the gigabit 0/0. In here, the 1.31 is registered over here, and the 33 is registered in the gigabit 0/1. But it's up to you though. You can register them vice versa, okay, whenever you're comfortable with, okay, as long as they are within this network IP address, you're good to go. All right, well, anyway, our goal in here our goal in here is to have this R4 join the EIGRP. Okay, all right, so first thing that we need to do is we need to join this 1.32 to this R1 EIGRP table, okay? Because as you see, it is directly connected to the R1. So let's do that. I'll open the R1, hit enter, enable, then COMT, then I'll type here router EIGRP1, okay? And then I will just add the network. So network 192.168.1.32, and then 0.0.0.7. There you go. Then Control C, and let me save the configuration. I'll close this, and I'll go to this R4. Or before we go to R4, let's go first here to the R3. So this is the R3, okay, as you can see. So enter, enable, COMT, all right, and then router EIGRP1. So what we need to do in here, so we need to add this 1.40 to the EIGRP routing table, okay? So network 192.168.1.40 0.0.0.7, Control C, and then let me save the configuration. All right, there you go. And I'll close this. Now let's move to the R4. So we need to add this to network, okay? And we need also, since this is a fresh router, so we have not enabled yet the EIGRP in here. So let's do the same thing of what we did to the R1, R2, and R3. Okay, so I'll hit enter. I'll type here, let's say enable. All right, and I already configured the host name, which is R4. Okay, that's good. And type here COMT, and then router EIGRP, then one, and then question mark. So we'll use the same command as we did on the other routers. All right, so no auto summary. I just hit the tab on the keyboard to complete the wording. So hit enter, and then EIGRP, then router dash ID. So this is, since this is R4, so let's make it 4.4.4, and then the networks be let's see here 192.168.1.32, and then 0.0.0.7. enter. Then I'll change this to 40. There you go. And what else? So we don't have computers connected in here, so we cannot use the what do you call this, passive interface. Okay, so we're good to go in here. So Control C. Let me now save the configuration. So if this R1 wants to communicate to this network over here, you notice that there is two paths to take. Okay, so it can either choose this first path, so from R1 to R4, and then to R3 to reach this network. It can also take this path though from R1 to R2, then to R3 to reach this network. So let us check though if what will the EIGRP will do. Let's see if the EIGRP will pick this path or this path. Okay, so let's open the R1 and then I'll go to the command line interface, hit enter, enable to go to the privilege mode, and I'll type here show IP space route, and then let's just type the EIGRP. Okay, so that it will display just the EIGRP routes. So let's see here. Okay, so you notice in here, so this is the 1.24. Okay, so we are on the R1, so it can actually see this network 1.24, and this is the first path. All right, so this is the best path. All right, and this is the second path. All right, so 1.2, we do know that this is the R2, and this is the R4. Okay, by looking on the IP address, so 1.34, and the administrative distance is 90, so 90 of course for EIGRP, and they have the same metric. Okay, 5632 and 5632 also in here. Well, why? It's because they are all connected using gigabit port, so gigabit port, gigabit and another gigabit port. Okay, and let's do some more observation. So let me type here again, show EIGRP, or let's type here IPEIGRP and then space question mark. So let's use this command, the neighbors. Okay, so let me type here neighbors. Okay, and hit enter. Okay, so we are on the R1, right? So let's pretend that we don't know what is the next router that the R1 is connected. So let's pretend. So by typing this command, the show IP EIGRP neighbors, then we can actually see the routers one neighbor. Okay, using EIGRP. So this is the first one, 1.34, and 1.34 is going from R1 to R4. Okay, and the next one is the 1.2. This is from R1 going to R2. Okay, all right, and then let's go to this topology. Okay, so I'll type here topology. I'm sorry, I'll use the up arrow key again, and let me just change these neighbors to topology. Okay. Okay, so by typing the command show IP EIGRP topology, then we'll be able here to see the available routes that the EIGRP can go. Okay, and as you can see here, the ID, all right, the 1.1.1.1, since we are on the R1, we do know that this is the R1 since it's 1.1.1.1. Okay, and by looking in here, you'll be able to see all of the networks. All right, so 1.0, 1.8, and then 16, 24, 32, and 40, but we'll focus more on this part. Okay, because as you can see here, it has two successors. All right, so this is the main route. All right, that the if the router one wants to communicate to the 1.24, so this is the best path. All right, so we do know that this is the 1.2, so from R1 going to R2, then R3, and then to reach this network. Okay, and then this is the second best path. Okay, and in Cisco CCNA, this is what we call the successor. Okay, And then the second one, this is the feasible successor. So let's go first here in the successor. Okay, so the support in here, this is the feasible distance. When I say feasible distance, this is the metrics, all right? So let's say here to this R1. Okay, so from R1 to R2 and then to R3 and then going to this 1.24. So that is the feasible distance. Okay, so from R1 to R2 to R3 and then to the 1.24 network. Okay, and then this one, this is the reported distance, the 5376. When I say reported distance, it should start to the router's neighbor. Okay, so this R1's neighbor is the R2. So the reported distance will be then from R2 to R3 and then to this 1.24 network. So that is the reported distance. You notice that this is a bit lower compared to this feasible distance. And definitely same thing on this feasible successor. So if it's the second successor, it's what we call the feasible successor. Okay, so same thing. This is the feasible distance, all right, and this is the reported distance. So the feasible distance is from R1 to R4, then to R3, then to reach the 1.24. Then the reported distance would be then the R1's neighbor then is the R4. So from R4 to R3 to reach the 1.24. So that is the reported distance to the feasible successor. Okay. And they have the same metrics though. Well, meaning if they have the same metrics, then the equal load balancing is working in the EIGRP. Okay, meaning is it has a backup route in here. Okay, they're equal. But let's say if you will experience a different number of metrics, okay, first successor versus the second successors, okay, so if they are different, okay, meaning that the unequal load balancing is working on the EIGRP. Okay. Other important thing that we also need to know in the EIGRP is in order to become the second best path to the EIGRP is there is a qualifications and requirements. And if it meets the qualification, then it will become then the second best path or the feasible successor. So in here, this is qualified to be a feasible successor. Why? It is because it will take a look on the reported distance to this feasible successor. It is lower than the feasible distance to the first successor. Okay, so that is why this is qualified to be a feasible successor in EIGRP. And if we'll try to compare the feasible distance to the first successor and the feasible distance to the second successor, they are equal. So again, the equal load balancing is working on this scenario. All right, so now let's discuss about unequal cost load balancing. And let me move it here. All right, so this is an example of a network that the unequal cost load balancing is running. Okay, so they're like the same design. All right, but the only difference is the label. So it's R1 here, and then over here it's a router one, and also the IP addresses. Okay, so in here, I put them in a class full. All right. Well, anyway, I just want to demonstrate to you how is the unequal cost load balancing is working. Okay. So let's say this is the R1, and we want to reach this network over here, the 192.168.6.0. Okay. So there is a two paths to take. This is the first one, and this is the second one. And you notice that this is the fast Ethernet, and this is the gigabit. All right, and this is fast Ethernet. So fast Ethernet. So let's see though. Let us see if what will the EIGRP will do. So will it um, show a two paths, all right, or two successor? All right. So let's check. So let's open the router number one and command line interface. I'll hit it, enter, and then I'll type here enable, and then I'll type here show IP EIGRP, and then topology. Okay, so let's focus on the network here. So 192.168.6.0, because this is the one that we're trying to reach, right? As you can see here, it has here two successors. So the feasible distance is 30,976. So this is the first successor, and this is the second successor. So as you can see here, so the 3.2, where is it? So from router 1, so this is the 3 network. So this is the 3.2. Okay, so it's from fast Ethernet and then gigabit. So this is the best path, all right? The first successor. And then this is the second successor. So, well, it's because this is a fast Ethernet and this is a fast Ethernet. So that is why this is the best. So EIGRP has chosen this one as the best path, all right? And let's go back, okay? And as we can see here to this second successor, if we'll try to check the reported distance, is 30,720. So it is lower than the feasible distance to the first successor. So it is qualified to become a second successor. All right. And you notice in here that the feasible distance, all right, to the first successor and the feasible distance to the second successor is different, right? So meaning in here that the unequal cost load balancing is running, all right? And I already enabled the unequal cost load balancing to all of the routers, all right? Well, it's just easy though, right? Well, I'll show you. So I'll go to the router one, all right, and let me just let's type exit first. All right, so I'll hit enter and then enable. Okay, and then COMT. All right, and then I'll type here router, so EIGRP, then one. There you go. And I'll type here question mark. Wait to see. So we're just gonna use the command here, the variance. All right, so we'll type here variance. All right, then space question mark. So from 1 to 128. So by default, the variance that is running to the all of the routers is number one. All right, so if the number one is active, meaning that equal cost load balancing is working. If we want to enable the unequal cost load balancing, then we can put variance 2, 3, 4, and then up to 128. Anyway, it's just a multiplier, but later though I'll explain it. All right, so let's put here number 2. All right, and control C. Okay, then let me type right to save the configuration. So I already put all of them to variance number 2. Okay, all right, so let's go back to the router number 1. Okay, and let me type here, or let me select here, show IPEIGRP, and then topology. Okay, so let's go back. There we go, and let's check the 6.0 in here. All right, so you notice here, this is the first successor, right? And this is the second successor. All right, so we enable the variance number 2. So what will happen to the feasible distance to the first successor? This will be multiplied into 2. All right, so if we will multiply this into 2, um, it will be around like 60,000 plus. All right, so by looking on this second successor, the feasible distance, it is within the range, of 60,000. Okay, if it's within the range, then meaning it is qualified for a unequal cost load balancing. All right, it's qualified because as you can see here is it is a showing, all right, that it's the second path and there are unequal. So I guess the next question is, what if like let's say let's pretend that this is 80,000. All right, so let us pretend. So what are we gonna do? Then if that is the case, then if it is on the variance number 2, then it is not qualified to run the unequal cost load balancing, because the maximum that it can only reach is around like 60,000. All right, but if we want it to be qualified for the unequal cost load balancing, then we can use the variance number 3. So this feasible distance to the first successor will be multiplied into 3. All right, so I think that's about like 90,000, okay, above. All right. And if this is 80,000, it's within the range though. So if that's the case, then the unequal cost load balancing will work. Okay. All right. And that's all about. If you like this video, please do subscribe to my YouTube channel, Dance IT Network, to get more updates about Cisco CCNA. And if you have any questions, suggestions, or requesting for any video tutorial, then you can email me, danceitnetwork@gmail.com. Thanks for watching. Bye.